material selection is integral to the whole product design process. How can a simulations tool help me with material selection?
Yeah, it's a great question, and one that is close to my heart because, as I said, my PhD was on constitutive modeling, material behavior, and how the response of the material changes based on the manufacturing process you pick. Right, so there are different levels, and again, I think this will give your listeners an idea of the career choices you could make. So at the beginning, you might have material like steel or plastics or rubber, which have their own characteristics, which I would say are reasonably well understood. But again, there are specialist materials that always come into play, right? So that, and then I'll explain how those choices affect simulation just a bit. But you could go to a different length scale altogether. Start saying, I need a material that behaves in a certain way. You might have a stress strain curve, or you might have a particular loading behavior, that response that you need from the material. Okay. And so how do you design a material? Okay. How do you pick the material, the microstructure? How do you pick the matrix and the other ingredients that go into that material? So that's a fascinating area for people who are interested in material science, right? So you're basically inventing new materials that then go into, start becoming used in your products. So to go back to your question, the material choices affect pretty much every product, right? So it could be the vibration characteristics. You want damping, you want it to survive accidents like a drop or something like that. It could be the protection. So you need to have materials that protect the occupant in the case of a car. And so there's material choices affect pretty much the entire behavior of the car. Where simulations come into play is, again, if you have the physics model properly, you can change the material and say, okay, instead of material A, I'm going to use material B. You run your simulations and you see how the product behaves. Is it still matching the design intent that you had in mind? Is it still going to survive the conditions that you had in mind? So it allows you to rapidly change materials and run your simulations, get an assessment of whether a new material is going to help you come up with a better design, maybe help you make sure that the product is going to last longer. So at the end of the day, make sure that the consumers are going to be satisfied with that. So simulation has reached a point where you can quickly switch materials, make assessments of how the product is going to behave. And it goes all the way. Now we're starting to look at tying together the different length scales as well. So we're at a point where you can say, okay, I'm going to design a new material with certain characteristics and tell me how is the final product going to behave, right? So connecting what might have been silos in the past. You might have a materials scientist working somewhere. Then there's a materials lab that does the test curves. Then you have the choices, the supplier saying, okay, I'm going to provide this to, again, a car or a plane or a phone maker. They decide whether that material is right for them. So you have these silos, and now it is possible to use simulation technology to say, what will a change at the microstructure level mean for the system level behavior of the product? That's pretty fascinating.